Okay, example one is going to be a quick one because they've graphed it for you. So it looks a little bit like this. In example one, you're going to be using the graph at the right to estimate the solution of the linear system. Then you're going to check it algebraically. So here's how this looks. They've taken equation one, probably put it in slope-intercept form, and they've got it graphed right here. Okay, so right here is the graph for number one. This thing right there, that line. Now, they've taken equation two, and they've put it right along there. Again, they've done all the work for you. Each one of these has unlimited solutions because they extend forever. But what we're going to do today is we're going to look for where do they appear to intersect. So where they appear to intersect is right there. So look at that point right there. What does it look like it's crossing at? And hopefully you're going to say it looks like it crosses at -2, -1. Now, one of our jobs is going to be to check to see does our solution make sense? Because when we graph it, sometimes it's a little bit off because our graphs aren't perfect. So what we're going to do is right here, we're going to substitute. We're going to substitute -2 for x, and we're going to substitute -1 for y because that's what we got right up here. So anywhere we see an x, we're going to put the -2, and that's in the first solution right here, first equation. So let's go right up here. Where there was an x was right there, because the original equation was x plus 2y. So we're going to put an x there. Where the y was, we're going to put a -1. Again, that's from what we think the solution is. And our question is, does this equal -4? Okay, so take a look at this. This right here is -2, and then right here is -2. 2 times 1 is, or 2 times -1 is -2. So we're asking, is -2 plus -2 -4? And that is going to be true. So we're going to say here that yes, -4 equals -4. That's good. So we at least know the first one's right. Now, the second thing is, we're going to go over here to the second equation, which was x minus 3y is 1. Again, where the x was, we're going to put the number -2. Where the y was, we're going to put the -1, and we're going to ask ourselves, is this true? Now, a little bit of mental math. I'm going to explain or extend this a little bit so you can see it. What happens here is this is -2 minus, and then the 3 times -1 is -3. Another way to write that is okay, so this is -2 minus -3, which is the same as -2 plus 3, which does equal 1. All right, so that one came out true as well. So 1 equals 1, and that's all good. So this one's good, this one's good, and here's how we think about this. Now, you don't have to write this out every time, but you want to think like this. Because -2, -1 is a solution of each equation, it had to work for both. That means that -2, -1 is the solution of this system. Again, system sounds like a big word, but we're really talking about two separate equations drawn on a graph.